Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Science Thursday, we're gonna talk about BLDC ceiling fans. These are a kind of requested topic and it's a very important topic because it affects you and me. So ceiling fan. Now ceiling fan are must-have home appliances. I'm pretty sure almost 100% of you have seen a ceiling fan one way or the another, and there is almost guaranteed that you have ceiling fan unless you are living in ludicrously northern areas where it's ludicrously cold. So in most of the time, ceiling fan is not optional, it's compulsory. It's almost like a light bulb. Like you get light bulb, you get ceiling fan. So it's a very big power consumer. So inherently there are a lot of engineers, a lot of government entities that are trying to make them optimum, simply because while a single fan itself is not consuming too much power, but the grand total power consumption is GG amounts of high. It's like ludicrously large amount of power is consumed in just cooling us. So in those sort of scenario, we want to use something that is more efficient. At this point in time, the technology that we are utilizing, it is time tested. So ceiling fans, they are time tested. That's why they are so integral to us. That's why like you cannot find any home that is without it. So single phase AC induction is a mode of transportation on which we utilize in this point in time, and it is inherently simple. All it is just a capacitor and some windings. You do not have to use advanced semiconductor or anything at all. It's dead simple. It has only two coils, basic windings. One winding is just like the main runner, and another winding is just like making sure there is a phase shift. So it has a rotating magnetic field utilizing only single phase, as it's not running on three phase. So ceiling fan, basically ceiling fan is a compulsory kind of technology. Now, what's the problem with this? If it's time tested, as in like almost time tested from a century point of view, what's the problem with this? Well, the first problem with this puppy is not very efficient. Even though it's an induction motor, it's not that efficient. Even though it does not have brushes or anything like that, it's only efficient to 75%. Now you'll be like, what is consuming that rest 25%? Technically, of course, there is friction and all that, friction, heat and all that jazz, but primary reason is slip. So if you look at the basically sinusoidal output of electrical energy, it's like, okay, electricity is saying the north pole should be here. You will find out that there is the rotor, basically the part that is rotating, it's not perfectly aligned, it's lagging behind. So basically north pole is here, north pole is chasing here. There is a slip, what we call in induction motor, that wastes a lot of energy. Now if you compare that and contrast it to BLDC can achieve 90% efficiency. That is tangible enough improvement. It's not like tiny, and I specified because of the large global use of ceiling fans, saving even a little amount in every single fan, that will translate to a huge amount of power saving. And one problem that was very specific to me is that induction motors really do not like square wave. They do not like square wave flat out. Now you may be like, why the heck your AC is square wave? Well, if you are utilizing normal inverters, most of them are square wave, unless you are paying a lot or you're utilizing online UPS. Most of them are generally square wave. So I have this issue is that in my upper floor I have a basic inverter, something equivalent to this, and it's square wave. Consequence of that is the moment power goes, but everything keeps running, but the only way I know that power has went up is my fan starts going from whoosh to starts to make noise, and it's very annoying and painful, and it has weird side effects, which includes the fan will be the quietest if you are running at full speed. If you are running at low speed, it's like it makes ear-piercing noises. So like again, it's annoying, it's almost like first world problem, but it's frustrating. And not to mention, it also overheats the coil, because coils are not the RMS value is kind of different in those sort of scenario. So yeah, there is some serious problem running on coil wave for a very long amount of time. Now our power cuts are like kind of regular, like 2-3 hours a day to 5-6 hours a day to almost like whole day. So in those sort of scenarios, it's not something that I can escape. It is compulsory. Like inverters, like we are consuming inverter, like we are on third or fourth inverter at this point in time. So you get the point. Like we have to have something that is more efficient, and for Indians it's like we have to have, like I specifically have to have something that does not hate square wave. So that's why we want to change from induction motors. Now BLDC, what does it do that makes it so efficient? Well, it basically takes the AC, makes it into DC. It just takes the AC, puts them into capacitor, puts them through the bridge rectifier and through inductor, and it's like voila, you have a DC water tank. Now that DC goes into a circuit that makes it into three-phase AC. Now why three-phase? Well, that allows you to have a rotating magnetic field, and the three-phase AC, many people know, no, it's just DC. No, it's AC. You can put it through a oscilloscope and you will get that oscillation signal. So it is AC, is just like different frequency. Now that's how they control the speed in this puppy. It's not resistor, it's not triac, it's very simple, basically frequency control. So you could literally have a design where it's like, hey, the motor, the ceiling fan is inherently designed to run from 60 hertz to let's say 120 hertz. So you could have a system where it's like, hey, circuit 1 run at 60 hertz, circuit 2, if you have 5 speed settings, so it's like circuit 2 run at 80, 90, 100, 130. That's up to you, depending on the engineer. Or some engineers could give you a remote controller smooth factor, where it's like, okay, from 90 hertz to let's say 120 hertz, like plus, 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 minus, 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 minus. That's up to you. So that is the core aspect, and that's why this puppy does not make noise when it's running on square wave, simply because it's not interacting magnetically, it's not interacting, and RMS value does not play too much role here, simply because it's just gonna go into a water tank first, like as in basically when the AC square wave turns to DC, it's more or less the same as a AC sine wave coming into DC. It's more or less the same. So what are the pros of this? Well, from company's point of view, it is easier to manufacture. While this puppy does require permanent package, which is not super cheap, it does not require too much of it. And because of the stator complexity on a ceiling fan, the machines that are required to make this puppy makes per unit cost bit higher. So let's say if this takes $3 to manufacture, from manufacturer's point of view, this puppy will take $3 to manufacture. That's including the cost of the magnet, because both of them are more or less the same. But you can easily see this puppy is super easy compared to this having two coaxial coil winding systems. So it is inherently cheaper to manufacture, and that money saved consumes by the permanent magnet. So from company's point of view, it's more or less exactly the same. Only difference is after you take the core elements is the driver circuit. Now because of the what we call the huge spike in electric mobility equipments and idiotically large demands of variable frequency driving in enterprise environments, we have like a completely large factories that are dedicated just to make variable frequency drive for motor. So that part is been taken care of by mass production. So that's why even you will think about like making a circuit that takes high voltage line voltage AC and converting it into DC. These things won't be cheap. They are not cheap. It's just they are cheap simply because we are manufacturing billions of them. So it does not hate square wave because AC goes to DC, so it does not hate it, and that's the primary reason why I bought it. And it's very energy efficient, so you can easily find ratings that will say, this is from the Crompton website, the company that I bought, is like 50% energy saving. Okay, that's good enough. 98% energy utilization of input power. That's awesome. That translates to really good utilization. And I'm pretty sure the engineers designed the basically packaging of this, because it says the power factor. You go to the website, they have specified the power factor is 0.98. That is really good power factor. Like normal ceiling fans have power factor of 0.9. 0.98, that's like almost good. That means the VA rating of your inverters does not need to be too damn high. So specifically, if you're talking about a school or something like that, and you have lots of fan, a company that makes a fan that is like much closer to that one rating, it gives you much more efficient utilization of power, and your transformer do not heat up. So that's really awesome. Voltage range. Now this is a very specifically an Indian problem, is that we have voltage that fluctuates like there is no tomorrow. So from 90 volt to 300 volts. So that's amazing. And this has another benefit, that speed does not matter. Basically does not get affected by input speed. So if input voltage is 200 volt, it still runs at the same RPM, because the DC tank, water tank, is acting as a buffer. So it does not get affected by it. So if I'm running on over voltage, I'm running on slow speed, the fan will still be in the slow speed. If I'm in low voltage and running at full speed, it still would be in full speed, simply because it's designed to operate within that range. And inverter friendly, which I get it why they are saying inverter friendly, which they're technically supposed to say square wave friendly, because ideally, like from in my ground floor, I'm utilizing a sine wave inverter and none of my fan makes noise. That's the ideal way, but I'm not that rich to buy inverters. Inverters are expensive. So what we can expect in the future? Well, one thing you have to understand, BLDC have to prove their longevity. While these companies are claiming like long life and all that jazz, like high efficiency, 5-year warranty, this puppy has like 5-year warranty. A 5-year, like I have ceiling fans that are older than that. Like I have working ceiling fans that are like around I think at bare minimum bought at 1992. So you get the point. Like these things are like not old enough where they can be like, no, we know that these puppies will last for 10 years or 20 years or 30 years. We do not have that data at this point in time. Another aspect is after sales support. Now I bought this puppy from Amazon, a link is provided down below. The primary reason is that if it blows up instantaneously, I connected it, it goes boom, I do not have to deal with call center. I simply have to say, Amazon, take it back. So fundamentally that's awesome for 30 days, but what after that? So this is one thing that you guys have to endure. Like I have already sunk my money into this puppy, so I'm hoping that this does not blow up the moment I'm out of my return window, and I should not need to utilize the warranty period. But this is one thing that we can only learn by going through this. There is no bypass this, there is any shortcut to this, so to say. And I also like the idea of Crompton design is simply because the driver circuit, not the coil circuit, the driver circuit is external. Basically it's on top of the casing. Benefit of that is that assume you have a fault, and the person comes in, the repair technician comes in, and they have to repair this. First thing they have to figure out, is the coil gone or is the driver circuit gone? 99% of the time the driver circuit would be the one that would be sacrificed, but you want to know that. How would you know that? This has externally, so all you have to have is a multimeter here, poke these three things, and these three cable, basically red, yellow and blue, and you will know whether the coil is short or not. So that's awesome. And because this thing is external, replacing it is super easy, because that is the weak link in this whole chain. And because India is a dirty power, I do not expect these things to last for like 10-20 years. 5-6 years, I'm do expecting 5-6 years at least, but 10-20 years I'm not. So what happens after that is, it's designed exactly how capacitors are designed in normal ceiling fan. They are designed as a replaceable item. So I really like this Crompton jam, because there are other ceiling fan manufacturers that are putting the driving circuit in the main casing, so you have to open the whole casing just to repair that damn thing. So I do not like that from a long-term point of view, because sooner or later this puppy is gonna fail and you have to replace it. And if it's very difficult, it's a very annoying or tedious, people will not want to replace it. You have to throw it a whole thing away. So from that point of view, I do like the approach that Crompton is taking, putting the driver circuit externally. And capital cost is the main issue. While this fan does not have extra bells and whistles, the only thing it has is the basically remote control, and you have to make sure that you do not have any regulator inline. Just remove all of those things. It's surprisingly less bells and whistles. Very simple aluminum cast as much as possible, no fancy hoo-ha, simple plain design. Heck, if I had bought white color, it would have costed me 300 rupees extra. I'm like, dude, I like my 300 rupees, I'm gonna buy the brown one. So I do see a lot of potential there, but we have to wait. Basically, somebody has to take the initial hit, which I have done already at this point in time, and hope this technology proves out like after 5 years or 10 years. And then every Tom, Dick and Harry over time will move into this, simply because unless everybody is super rich, most of people can't afford to move to a sine wave inverter. And on top of that, even if you can afford to move to sine wave inverter, having a system that has better power factor and lower power consumption is awesome anyway. So I do see a bright future, but we have to go through to that future to figure it out. So this was my presentation on BLDC ceiling fans. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment, because I do try to reply to all of them. And subscribe, press the bell icon if you're free. And as always, thanks for watching.